A ball 1 moves with a velocity of 1.1 meter per second in the x direction and strikes an equally massive ball 2 initially at rest. Ball 1 deflected so that its velocity has a component of 0.7 meter per second in the x directions and a component of 0.46 meter per second in the y direction. What is the velocity of ball 2 immediately after the collisions? I want you to pause the video and try to solve this problem yourself first. To solve this problem, first you need to create a drawing before the collisions and after the collision. So let's capture all that information in the drawing. So we have mass 1 moving with a velocity of 1 meter per second into mass 2, which have 0 meter per second. After the collisions, we have ball 1 has a component of x component of 0.7 meter per second in the x directions and 0.46 meter per second in the y direction. We need to figure out ball 2 velocity. Now that we have created a drawing, we're going to go into the law of conservation of momentum to solve it. Now we capture the drawing in a mathematical model. So momentum before equal momentum after. We can write it Pi equal Pf. I stand for starting, initial, and F stand for final. So now we expand that equation into this. This right here captures all the information in the drawing. So let me show you where the information belongs. That's mass 1. That's velocity of mass 1 at before the collisions. Mass 2, velocity of mass 2. Same thing, mass 1 after the collisions, and mass 2 after the collisions, and that's the velocity of mass 2 that we need to figure out. We know that V1 velocity of mass 1 after the collisions is equal to 0.46 I hat and 0.7 J hat. I hat right here is just referring to the x directions, and J hat in physics just means in the y direction. So this information is given in the problems. So I'm just reproducing it here. So if I take that information and put it into this equation right here. Again, I'm just transfer the information down. I'm transfer m down. I input the number now, 1.1 for the starting velocity, and then I'm just again inputting the numbers for the equation above. Mass, any number multiplied by 0 is 0, so I can remove this right here. And the equation becomes that. And I pull out the m from the right side. And what I can do next is I can cancel out the m from both sides. And if I subtract V1F from both sides, I will, from the right, I will move it to the left, as you can see there. Now I have V2F by itself. V2F is something that I want to figure out in this problem. Let's move over here to get to have more room. So now I just again input the information that is given to me. 0.4 meter per second in x direction. I just take 1.1 minus 0.7. That's how I get 0.4. And then I just minus 0.46. Remember that I have a minus out here. That's why it's a minus sign down here. Alright, so now I need to figure out the magnitude of the vector v2f. I just need to take a square root of v2f in the x directions, square plus v2f in the y direction, square and square root of that. That's the equation for finding the magnitude of a vector. And then I just transfer the number into the equation, and that will give me 0.6 meters per second. That's pretty much it.